maybe. You were handed a semester exam study guide. In my next slide, I'm going to bring it down and not make it as big to the best I can what I got at the moment. So it's 1,000 pages. Sorry for that. Don't get freaked out if there's lots of space between problems. There are 124 problems, so it's going to be 124 points and a 30% grade. Doesn't matter if you're exempt or not, you have to do the semester exam study guide. Now that sounds depressing, but the good news is I'm literally going to tell you all the answers. We're going to go over more than the first 10 right now. So genuinely, as long as you're paying attention when we do our math workshops, you should be good to go. And it should just be an easy grade. And what I'm going to do is I'm going to take Kylan's and flip through it and like, did she cross off number 4 because I'm not doing number 4? That kind of thing. Like, are we on the same page? So literally just paying attention during math workshops and she's going to get a good grade in sort of the category. Okay, let's go ahead and answer some of those, and then we'll talk about the rest of our plans for today. Let me say more words about that now. If you think you are going to be exempt from the semester exam, that's terrific. I'm not looking into that until Friday. Why not until Friday? Well, 1, because you have tests on Friday, so I have some free time. 2, a lot of us are missing a test or a quiz from last week. You didn't come to school last Monday and Tuesday, that's fine, whatever. Now, I haven't typed in the 0 yet. I will on Friday, and then I will consider that when I look at whether or not you're exempt. So as long as you fix D0 by Friday, you're good to go. We took a math workshop test, and you went in the 60% category, and we took a completing the square / quadratic formula quiz, and it went in the 30% category. If you took the math workshop test and did poorly on it, I'm so sorry. No takebacks, no returns on that. I don't know what your deal is, but I can't help you with that. If you took the completing the square and did poorly on that, when it comes to me about a retake, you can. There are at least 3 in this room who didn't do nearly as well as they should have because it was 5 problems. The first 2 said complete the square. You know what? They didn't complete the square. They used the quadratic formula. So if you don't complete the square, you don't get your points. So anyway, those are all the reasons as to why we're going to wait on whether or not you're exempt from the semester exam. Let's look at number 1 on the semester exam study guide. It says we have a minus y squared plus 2y to the 3rd, and they tell us a is 2 and that y is negative 3. They literally just wanted to see, can you keep up with all the different signs? 2 minus an 8, if you have on a number strip, I'm about to give out a lot of points if you haven't pulled one out already. 2 minus a negative 3 is a positive 5, so 5 squared. And plus 2, negative 3 cubed is negative 27. So I've got 25 minus 2 times negative 27 is... Jackson's group gets a point, which means my final answer is A, and Karen's group gets a point. Okay, number 2 is what kind of a problem? Number 2 gets a point, table 2 gets a point. We still are just plugging in stuff. So it was, I need to write that in, it was negative absolute value 3c minus d. They tell us that C is negative 1. They tell us that D is 5. So what should my final answer be? Yes, so it should actually be D. And you can have a point because you did correct it, and Jax, you can have a point as well. So it was the absolute value of negative 8. Which I get is positive 8, but that negative sign over here has been on the outside of the bars the entire time. So the answer is D. And again, these are literally just trying to trick you with signs. That's the only way you're going to mess this up. You have issues with signs. The next problem says 4m to the 3rd minus 3m squared plus 2m minus 2. And they tell you m is negative 1. This is a good problem for me to say if you are one of the unlucky souls who has to take the semester exam. This would be one of those questions you want to ask me about because you want clarification about the exponents because that 3 and 2 are super tiny and you want to make sure it really is a 3 and a 2. Well, -1 cubed is -1, whereas -1 squared is +1. So I actually end up with what answer? It ends up being B, that's 2, 4, and 5. So -4 minus 3 minus 2 minus 2, -7, 8, 9, 10, 11. And it does end up being -11, which is B. Number 4, you can put a mark through, so we're not going to do that one. If there's one on the semester exam like that, I'm literally going to tell you the answer. Sum of the first n natural numbers. Find the sum of the first 20. So, literally, we could just plug in a 20. It's really not that complicated. They're telling you there's a formula, and it's 20. So we're just going to do 20 times 21 and divide that by 2. It's not that deep. It's just we haven't done one like that before. Why would we suddenly pull that out for the semester exam? We're not going to. Okay, then we get to number 5 where the fun happens. It's been a long, long, long time and we've forgotten about classifying numbers. Remember natural, whole, integer, rational, irrational, real, that kind of thing. So it wants to know which represents a rational number. Why is it B? Because the square root of 36 is 6. In fact, we had a math workshop the other day where we talked about if it was the square root of a number that's not a perfect square, it ends up being irrational every time. So 17, 50, 101, those are not perfect squares. So it only was 36 because that is a perfect square. Good grief, that took a while to get out of my mouth. Number 6, still on this number classification thing. Which real number is irrational? Irrational, and there were 2 things we were looking for. Or the 2 things we were looking for. If something's irrational, it was this and this. And what's the other one? You can have 1 point for that one. What's the other one? So non-terminating, it's not B. That terminated, meaning it ended. Every group can have a point. Non-repeating. So we know it's not C because C is implying 257, 257, 257, 257. I was thinking the answer was going to be A. What should I do to check that?
You should do 27 divided by 5.
In my calculator. So let's see, 27 divided by 5. I get 5.4. That's terminating. So it's not A, so the answer is D. The ... means we don't know what's next. Okay, so let's go on to number 7. So in number 7 it says, name the set of numbers to which -28 belongs. Where does -28 belong? I heard C. There's only really one wrong answer. What's the one really obvious wrong answer? That's the one I thought was wrong, obvious. I thought it was B, because of natural. Naturals can't be negative, so it can't be B. -28 is an integer, yes. But that's an option on A, C, and D. -28 is not a decimal, so it's not it's terminating, it's good to go, so it's definitely rational. But isn't negative 28 also a real number? So when we were doing our number classification system, all the ones we were talking about were real numbers. We didn't get to non-real, which was the complex numbers, until recently. So number 7 is D. Number 8, I'm going to go ahead and distribute that 1/2. So I'll have 4y minus 5z. If I distribute that negative, I'll have negative 3y minus z. If I combine my like terms, 4y minus 3y, I get positive y. Negative 5z minus z, I get negative 6z. So my answer on number 8 is A. Now, I'm literally working all these out for you today, but that's not how tomorrow is going to go. You were just handed it today, so I feel sorry for you, so I'm working them all out. Tomorrow, if they're easy ones, I'm going to tell you the answer and skip them. Number 9, select the algebraic expression that represents the verbal expression twice the sum of a number and 8. It's C. 5 corrected it first, so 5 can get the point. It says a number and 8, and they want twice that sum, so the answer should be C. Number 10 is very similar. Select the algebraic expression that represents the verbal expression 5 increased by 7 times the number.
Yeah.
What's the answer?
D.
The answer is D. Every group can have a point. It says 7 times the number, so we know that's 7n, and then increase by 5, so 7n plus 5, so it has to be D. Again, if you forgot how to do those, always find the unnumbered, because I know that's where the x or the whatever the variable you're using goes. I used n because they were using n. And that's where I start and then think back. Okay, number 11, we get to solve an equation. Woohoo! If we distribute the 3, I think you're wrong. We'll have 15x minus 3 equals 3x plus 3. If I subtract 3x from both sides and put all my x's on one side, I'll have 12x minus 3 equals 3. If I add 3 to both sides, I have 12x equals 6. So I get x equals 6 over 12, which reduces to 1/2, so my answer is 8. My answer is A. 12 is my favorite of the day. Why is 12 my favorite? I do like the absolute values. What's the answer on number 12? Which one is it, Jack? I like it because people have forgotten things. You've forgotten, and I remember writing this on 1,000 tests, so I haven't forgotten absolute value problems. I have 2 answers. I should get a stamp with that. I write it a lot. They have 2 answers. Because we're debating that inside jump. The inside jump, the x minus 5, is it equal to positive 4, or is the inside jump, the x minus 5, is it equal to negative 4? Because we're not sure, because those bars made it positive. So before those bars came around, was the inside positive or was the inside negative? We don't know. So we get x equals 9 with this equation, and x equals 1 with this equation, so the answer is C. But of course, most people are going to pick A. I heard one person say D. What would x minus 5 need to equal in order for the answer to be D? With the bars. Say it again, Gilberto. Negative 5 or negative 4, you can have a point. Remember, we had a whole discussion about the bars. No, we're not talking about the inside the bars. That's what we were messing with. But once the bars have been applied, you know an absolute value problem cannot equal a negative number. So the only time we would get no answers at all, or no, there's no solution, we would get D if they tell you the absolute value equals a negative number. Okay, we will stop right there for today. We're going to do a lot more tomorrow. Our goal for tomorrow is to go all the way through 29. That would be wise. It would be smart to go ahead and try them out, and then we just go over the answers. That would make our life faster, and we get through this faster. But my goal tomorrow is to go through 29. Okay. Let's pull out your old packet of notes. You have it somewhere. We never finished it. We got to finish it now. That's what we're working on this week. Which part of this do you think is in there too?
I have to do the quadratic.
Okay.
I think I may have like 1 or 2 left on the...
Angel, I don't need clarification. Which part do you think I'm going to say no to?
Oh, yeah.
Okay, let's talk about what Angel's already on it. Good for her. Let's talk about what you forgot about since you've been off. So we took a quiz on completing the square and on quadratic formula last Monday, and most of us finished it up on Tuesday. You were given some homework the week before. Most people never showed it to me. I have quite a few zeros in for that. That's one thing you would like to fix before Friday. So if you look, our packet starts on page 21. What I'm referring to is on the next page, page 22. I gave you the 5 problem answers. I said, hey, try to complete the square. Here are the answers. Did you show me you tried page 22? Most people, the answer is no. So that's 1 0 you can possibly have in right now. And now another 0 you possibly have in is on the very next page. This is page 22. Flip to page 23. You had 5 problems you were supposed to try with the quadratic formula. Most people never showed me their page 23 either. It's fine, we can fix it, but at the moment you have a 0 in for it. So when I get done rambling, yes, you do have 3 problems from your workbook tonight, but it would also be wise to make sure you're getting this done to fix these zeros. Okay, so we've talked about completing the square. We've talked about the quadratic formula. We've talked about how people missed that quiz, but regardless, so we're pretending that you've already done it. There's still a little bit left, and then we're done with chapter 4. So we're going to take a test on Friday that has the second half of chapter 4. So it's going to have completing the square, it's going to have quadratic formula, and it's going to have what we're talking about over the next couple days, which involves vertex form. So today we're on page 25. Today we're on page 25. Just a reminder, there's some stuff you should recall about quadratics. So there's some sort of equation. The highest exponent is the second power. We've talked about x-intercepts, y-intercepts, lots of things, but something we're going to focus again on today, as it says in the directions. We need to know the vertex. We need to know the axis of symmetry. We're going to talk about the shape, which is not something we normally discuss, but we're going to discuss it today. So it's okay if you put a star by this one, because it's okay if you don't know that one yet. And we're also going to talk about the direction, meaning the direction in which it opens. Does it open up or open down? Now, let's face it. Some of us recall the formula for axis of symmetry is negative b over 2a. So some of us could have found all this without actually following directions today. And then all of us, well, theoretically, if we paid attention, all of us should be able to, with our graphing calculator, graph it determine where that min happens, which would be the vertex, determine the axis symmetry, and all the other things from our graph. And never am I ever taking the graph and calculator away from Tylen, so she can always check herself with that graph and calculator. Okay, I can fill in the direction already. Is it up or down? How do you know it's up? Because it's a positive one in front. Your group can have a point. Okay, so we will want to put this in vertex form now. So I understand you and I can do all of this on our own without following directions, but it's like those who did the quadratic formula when they were supposed to complete the square. Did they technically do what they were supposed to do? No. Are they getting all their points? No. So it says write each function in vertex form. We've got to get to vertex form first. They tell you what vertex form is up above if you want to look at it. You've seen this before, but we weren't talking about parabolas then. What kind of graph were we talking about when we used to talk about a vertex? I'll give you 2 points. Spent a lot of time on them. It's not linear functions. There's another kind of function, and we would talk about its vertex a lot. You can have 2 points over their absolute value functions. What we're going to find out today is that quadratics, absolute values, basically any kind of function, follows the same sort of rules. So the fact some of it's going to come back to you, and it's really going to be the same. Here's the depressing part for those of us who weren't paying attention before the break. I'm going to show you how to do this by kind of completing the square. So if you didn't pay attention to completing the square, good luck writing the function in vertex form. Okay, so if I'm writing it, if I'm completing the square, you would say x squared plus 4x plus something. But it's not exactly what we were doing a week ago or a week and a half ago, because it used to be if I added the something on one side, I subtracted the something on the other side. Today we're actually going to make life even easier. Well, I think easier. You might think more complicated. I can't. 6 didn't go away. He's still out here. He's just not part of completing the square. We used to subtract him and move him, but darn it, now that y is on that side, so we're not going to move the 6. We're just going to exclude him from our parentheses. Okay, so we used to, if we added something on one side of the equation, we would subtract something on the other side in order to balance it out. Today, we still need that balance, but we're going to do it both on one side. Now we can add to something and subtract to something. So if I add 3 and I subtract by 3, aren't I really adding 0? If I add 4 and I subtract by 4, aren't I really adding 0? So as long as whatever I add by, I subtract by it, we technically haven't messed anything up and broken any rules. Okay. When we complete the square, we were taking the middle and doing what? 2 and 4 get a point. We did middle divided by 2 squared. So if you've forgotten, we're still doing middle divided by 2 and squaring it. So our middle is that 4x. 4 divided by 2 is 2. 2 squared is 4. So middle divided by 2, 4 divided by 2 is 2. That's what goes on the next line. 2 squared is 4. Are there any questions about the 2 numbers I have written in green? Okay, but since we're going to add by 4, we're also going to subtract by 4. We've added 4 and we subtract by 4 and it ends up counteracting. So, positive 6 minus 4 is positive 2. So lo and behold, I now have my parabola in vertex form. Because if you're looking at the top, it says something, something H and K, and they had it in parentheses and something squared. We have it there. Now, here's the part I wouldn't guess this. Because 4 divided by 2 is 2. 6 minus 4 is plus 2. Yes, thank you, Ellie, I understand. The other plus 2. Okay, yeah, thank you, Ellie. Here's the part where you're supposed to remember what we did with absolute value functions. When we would write the vertex, yes, the outside number, the plus 2, does actually mean up to. But the inside number, it moved us left or right, and there was something special about it. Do you remember? Yes, it's the opposite sign. You can have another point. You're okay. It ends up being the opposite sign. So just a reminder, whenever we get anything in vertex form, parabolas, absolute value functions, any kind of functions in this vertex form, the x-coordinate is actually the opposite sign for the vertex. So it was plus 2 in our form, but that actually means minus 2 in reality. But darn you, y-coordinate, it ends up being the same. And if you think I'm crazy, then look up at the top. It says specifically x minus h squared. So really we're saying x minus negative 2 squared. So that's why it's supposed to be negative 2. And that's real deep. We're not going that deep. Here's the fun part and the easy part. What's the axis of symmetry? My heart is literally breaking. My heart is literally breaking. What is the axis of symmetry? The axis of symmetry and the x-coordinate of the vertex match. The x-coordinate of the vertex is negative 2. So the axis of symmetry is negative 2. I want to cry. Did you? 3, you can have a point. You can have 2 points. If you had spoken up, I'd give you all the points. Okay, you were supposed to know that. I'll give you the one thing you don't know is shape. But you're supposed to know that. We talked about that with absolute value functions. So remember, absolute values were the B's. And we would talk about their shape as in were they made skinnier or fatter. Or, you would say shrunk or did we, how did we stretch it? Did we shrink it? That kind of thing. I like skinny fat, but I get stretch and shrink. It sounds more mathematical or whatever. So we used to take an absolute value, and if we multiplied by a certain number on the outside, it would make it skinny. And if we multiplied by a certain number on the outside, it would make it fat. What made me fat? Do you recall? You can have a point for that. Fractions make you fat. But I don't see any like a 3 or a 1/3 out here, do you? It's just a 1. So it's not, I'm just the same. I'm a parabola. I'm not a V now. I'm a U. But I'm just the same. So it's really not important to even put the shape when there's a 1 there. Because I'm not stretched, I'm not shrunk, I stay the same. My vertex might move from 0, 0, but I stay the same U that I was. Okay, number 2 is 1. We'll go to 3 first. Why do you think I'm going to go to 3 next? Yeah, so, and it's what Angel's saying too. So 2 and 5 can have a point. Angel's saying 2 has a shape because of that 2 out front. And Ellie's saying I'm picking number 3 because the 1 out front of the x squared, and she's right as well. So I still need to know vertex, axis of symmetry. Shape is again going to be silly because I'm not going to be stretched or shrunk any. So if you want to cross that one out, I get it. And then the direction should be what? Ellie's group missing another point. Direction's up. Okay, so again, I'm just trying to complete the square. So it's x squared plus 2x plus something. And then whatever that something is, I'm going to subtract it from 7. So I added something, and I'm going to subtract something. That's how it's going to counteract. But still, like completing the square, I'm going to do middle divided by 2 squared. So the middle is what number? 2 divided by 2 is 1. 1 squared is, so middle divided by 2 is 1. 1 squared is 1. So literally I have 7 minus 1, which is positive 6. Are there any questions about what we got in green? Intentionally so. These problems are picked specifically for that purpose. Because if they had a fraction of front, like the 1/3, would it even be worth doing this? Because again, we always want to do that on our calculator. Okay, so the vertex is what? To set it first, thinking of the point. My axis of symmetry is -1. We're not worried about the shape. The direction's up, so yay. That one was easy. Now to deal with 2 and 4, darn it, there's not a 1 in front. Oh, vertex. Axis of symmetry. Oh, you can't see my body. That would help. And direction. My direction is up. And this time we're actually going to talk about the shape. Okay, when we were completing the square before, I'm going to write the first step first. So we had 2x squared minus 12x. I put a plus. That's minus 12x. Plus something. And then we have plus 17 minus something. Okay, when we were completing the square before, and there was a leading coefficient that wasn't a 1, what were we doing? Yeah, so we would end up, kind of reminding me of that slide divide bottoms up method we were doing with factoring. Like, we would move that 2 down to everybody. We're not going to do that today. Honestly, that's great and all. There's an easier way with vertex form. So if you were a little worried when the leading coefficient was a 2, it actually is going to work out nicely for us. Now, I get we don't know what the something is, but we do know the 2 and the -12. I get they both have an x. We're not going to factor out an x. Forget the x. But besides the x, there is a GCF between those two terms. What is the GCF? Let's pull out the 2. If we factor out a 2, we would be left with x squared minus 6x plus something. Again, I'm assuming that 2 will go into whatever that I get. I'm assuming a lot, but I'm choosing the something. So can I choose something that's divisible by 2? As long as at the beginning I choose like 20 and not 19, then we're good to go. I get that I should probably put plus 17 minus squiggle, but I'm getting kind of lazy, so I'm not going to write it anymore. Not on the second line. Over it. In fact, I'm just going to see the front part all the way through. Middle divided by 2 squared. So -6 divided by 2 is positive or negative. And then squared, we get 9. Does everyone understand where the pink came from? Middle is -6. -6 divided by 2 is -3. -3 squared is 9. So I got the -3 and the 9. Does everyone understand where that came from? Now you would think, okay, Miss Compton, so go back to that top line, put plus 9, minus 9, call it a day. You would think that, but that's not actually what we're going to do. You and I made this step happen, didn't we? By factoring out a 2. So when I go back to that top line, I need to pull the 2 back in. So that top line was actually 2x squared, because 2 times x squared was 2x squared. -12x, because 2 times -6 is -12. And that top line ought to be 18, because 2 times 9 is 18. We factored out a 2, we've got to give him back. So since we're adding 18, I need to subtract by 18. Does everyone understand where the 18 came from and not a 9, why it's an 18? Okay, 17 minus 1 is -1. And that's how Miss Compton gets lazy. Once I figure it out on that top line, 17 minus 18 is -1. I just put -1 the rest of the time. Makes life a little easier. So now we have it in vertex form, which is supposed to make our life easy. What is the vertex of my... Thank you, you can have a point. My vertex is 3, -1. Which means my axis of symmetry is 3. And now for the word we haven't used. Everyone can have a point, so that was helpful. What's the one word we haven't used? Shape. Shape. So what should I put about that? 2 is what I'm looking at when I think about my shape. 2 is shape. They go together. Is it going to stretch me? Is it gonna, how is this, am I getting fatter or skinnier? You're getting skinnier, so I don't care if you put skinny. But if you want to put that you're stretched, because you feel like that's more mathematical, that's fine too. Again, I used to be a U, and then that 2 in front has made me a bit of a skinnier U. I'm still a U, but I'm skinnier. If it was a fraction, then I would be fat. But it's a whole number. It's a 2, so I'm going to be skinnier. Are there any questions about number 2? We've got one more, and then it's on you. I'm done. I told you, well, this is not hard if you recall completing the square, but if you tune out during completing the square, and you tuned out only the absolute values, then you are out of luck. Okay, so we still need to know the vertex, the axis of symmetry, the shape, but I already know the direction. It's our first down one because of that negative out front. And at first I was kind of concerned when I saw it was a -4, but it's still going to be okay. So again, I've got -4x squared minus 24x plus something. And then whatever that something was, I need to subtract it from 15. I added it, I need to subtract it as well. Yes, but be more specific. Yes, 2 can have the point. Okay, so next line down, I'm trying to pick out a GCF because I'm tired of that -4. I don't want to deal with it. Guess what? Everybody's divisible by -4. Again, I'm picking that something, so darn it, when I'm done, it's going to be divisible by -4. I pick it. So I'm left with x squared, -24 divided by -4 is plus 6x, and then plus something. Don't know what that something is. I'm working on it. All I know is I've decided everybody was divisible by -4. Now I get to take that middle, divide by 2 and square it. So 6 divided by 2 is 3. 3 squared is 9. Does everyone understand where the black came from? How I got x plus 3, because 6 divided by 2 is 3, and then 3 squared is 9. Any questions about the black? Okay, so again, you think, because people just want life to be easy, and I get that, you would think, hey, you picked your mystery number of 9, so add 9, subtract by 9, but that's not what we actually did. We factored out that -4 first, so we need to give that -4 back. So it's actually -36. Because it was -4x squared, -24, -4 times 9 is -36. So I'm going to have a -36. And this reminds me of that problem we were just doing with our semester exam study guide, because it all comes up with signs. It's all about can you keep up with signs. What do I actually have on the right? I've got -15, but what else? It's actually plus 36, because two negatives make a positive. So I've actually got 36 and a -15. 36 minus 15 is... So -15 plus 36, you get a positive 21. And this is the first one that actually was... I'm not trying to be ugly, but all the others we could have easily checked with our calculator, because that vertex would be seen in our standard screen. But with that y-coordinate of 21, you would have to zoom really far out for that one. So maybe vertex form does make our life easier. Maybe. So my vertex is at -3, 21. My axis of symmetry is at -3. Would be helpful if you could see. My shape is still skinny, because that 4 is making me skinny. I might be an upside down U, but originally I was like this, and now it's making me super skinny. It's a good problem. So you can put skinny or stretched. I highly doubt we do one in Vertex form. That's what me and Daniel were secretly discussing earlier. I highly doubt in Vertex form we make you do one that makes you fat, because that would mean we factored out a fraction. And it's kind of like the completing the square ones with fractions. Why on God's green earth are we doing this? Isn't it just easier to do it in our calculator at that point? Okay, it would be smart of you to go ahead and do your 3 workbook problems, or to work on page 22 or 23. If you want to come show me something like Angel does, here's your chance. In just a moment when I get done seeing things, I'm going to show you the tests and stuff I do have graded.